Hamzetra. We are from Group 5. We want to present our group project assignment. So our topic is effect of sunlight exposure on plastics degradation. This is our group members. So my name is Nur Azmin Shazala Mitiabu Sama. So my second member is Nur Lala Shafia Binti Azhar. My third member is Siti Zara Binti Khalid, and my last member is Aina Jiha Binti Jamaluddin.
Okay, so now we will be discussing about the overview, the objective, and introduction. So basically for the overview, our group has been given the topic of research for three types of sample plastic, which is PET, polyethylene terephthalate, LDPE, low density polyethylene. Our group has been given the topic of research for three types of sample plastic, which is PET, polyethylene terephthalate, LDPE, low density polyethylene, and PP polypropylene. Where we had been research for several weeks to know the degradation of the plastic. So for the objective, there were several objectives from the research, which is the first one, you have to know how the physical change of the plastic through the degradation impact. And the second one is to know the one that is exposed and the one is unexposed to the sunlight, how much the degradation change, and so on. And lastly is to know the most affected type of plastic, which is either the PET, the PP, or LDPE. Okay, so now for the introduction. For the general history, you have to know that polymer or plastic, PET, LDPE, and PP is usually the cost-effective type of plastic, and it is durable and easy to produce. Other than that, we have to concern about the pollution and the UV degradation to the environment exposure. And lastly, for the UV radiation and sunlight effect, we have to know how the UV radiation does to the polymer change that will broke and weaken the chain of the polymer. Other than that, there was also the difference between PET, LDPE, and PP properties, which is for the PET, it is usually easy to get the UV degradation, while for the LDPE, it is faster to moderate to the digestion of the UV degradation, while for PP, polypropylene, it is moderate to the change of the it is moderated through the change of the properties due to the sunlight. So for this research, basically we had been observed the physical change of the plastic properties, so that we know how much degradation does to the plastic properties.
This is my part methodology. For point first, material selection. 3 plastic materials were used. For number 1, 1 green PET drink bottle, an LDPE plastic bag, and a PPE rope. Indoor controlled samples were kept away from sunlight for comparison. So number 2, experimental location exposure. So for the explanation, the experiment was carried out at UTHM Parit Raja. The samples were placed outdoors and exposed to sunlight, rain and wind, receiving about 4 until 5 hours of direct sunlight daily. So this is our sample for our project. Third point, observation and recording method. So the observation focused on visible change in each sample, including color fading, surface gloss or dullness, transparency, change in the LDPE plastic bag, and any surface damage such as cracks or deformation. So for the last point is procedure. All samples were cleaned and dry before being placed in their respective conditions. The exposed samples were hung outdoors, while the control samples were kept indoors in a dry, shaded area. Observations were carried out once a week for 4 weeks, with exposed and control samples compared side by side.
Next, I will talk about data collection and analysis. First, we expose the sample for PET, LDPE, and PP in the sunlight for 4 weeks, and then we record the physical damage using phone and notes every week. First, I will explain about PET. For PET, from week 1 to week 4, it only showed a slight color fading and a bit less gloss. However, it is only obvious when we compare it side by side with the controller we kept in the shade. So, PET is still the most resistant to photo degradation in our test. Next, I will explain about LDPE. For LDPE, for the first 2 weeks, there is no obvious changes when we compare them to the control samples that we kept in the shade. However, from week 3, the plastic bag began to lose its original color and look less vibrant. From week 4, the fading was quite clear, and we can see it by the picture given. This shows that LDPE has medium resistance at the beginning, however it degrades more over the time. Lastly, I will talk about plastic type PP. For plastic type PP, we can see here that the color was already fading in week 1 and it kept increasing week by week. And by week 4, the most of the color was already gone when we compare it to the sample that we kept in the shade. And this conclude that PP is the less resistant to the sunlight among these 3 samples that we have done. Next, I will talk about the result of our experiment. To make it obvious, I put the samples that has been put in the sunlight and that we keep inside side by side for the comparison. For this one, we can see that PET shows only a little bit of fading, but the end look still almost like the control. For LDPE, there was a clear fading, but the shapes remain its original. However, PP has lost most of its original color. Overall, we can conclude that PET is the most resistant to sunlight, LDPE is in the middle, and PP is the least resistant to sunlight under our condition.
Okay, now I'm going to share discussion from our project. First of all, comparison with theory. PET, LDPE, and PP are expected to degrade under UV exposure. But in our experiment, PP faded from the first week, followed by LDPE faded after, and PET showed only slight change, indicating that PP is the best UV resistance. Lastly, this trend agrees with previous studies, while the absence of severe cracking is due to weaker UV intensity and shorter exposure time in our experiment. And then why our result look weaker than theory? First of all, our result were weaker than theory because of the experiment real outdoor conditions, and then the sample received only 4 to 5 hours of sunlight per day with changing weather, so UV exposure was lower and inconsistent compared to lab studies. And lastly, sample thickness and color also matter. Thick green PET block UV and show little change, while TD, LDPE and PP show more fading, with PP being the most UV sensitive. Lastly, limitation and suggestion. First of all, our experiment had limitations such as short exposure time, partial sunlight, and possible shading, and reliance on visual observations. As a result, only early degradation or color fading was seen, not severe damage. Lastly, future studies can improve results by using longer exposure, full sunlight, controlled UV lamps, and it is simple mechanical and mass measurement. Okay, lastly, for our conclusion from our project is overall this project helped us understand how PET, LDPE, and PP respond to sunlight and how their structures influence degradation in real outdoor conditions. In conclusion, PET showed almost no visible change. LDPE stayed stable at first but faded in later weeks, and PP faded the fastest. So PET was the most resistant and PP the least resistant to visible photo degradation under our conditions. We achieved our main objective of observing and comparing physical change, but the degradation was weaker than theory because exposure time and daily sunlight were limited. In future, longer exposure and simple mechanical tests are recommended to observe more advanced stage of degradation.
So this is the list of references that we have been used for our group project. Thank you.